Hi, I'm Shannon Seaver, and today we're going to be talking about solving rational equations. And I thought I would let you see my little doggy, Bimmy, before we get started. Can you say hi? Yes, this is Bimmy. Okay. So what we're going to do today is we're going to solve rational equations, and we're also going to talk about some limits in terms of what the answers can be. So our first example here, we have x over 5 plus 2x over 4 equals 11 over 2. And when we have fractions, when we're going to solve them, we got to get a common denominator before we can do anything. Here we have 5, 4, and 2, and the very first thing that I can think of is I know that 5 times 4 is 20, and 2 goes into 20. So I can use 20 as my common denominator. Therefore, I'm going to take every one of these and multiply them by 20. When I do this, this allows me to get rid of my fractions. So now 5 goes into 20 how many times? 4 times. So this becomes 4x. 4 goes into 25 times. So 5 times 2x is 10x. And 2 goes into 20 10 times. So I have 11 times 10, which makes 110. Now what I want to do is simplify or combine like terms. So if I do that, I get 4x plus 10x, and that makes 14x equals 110. Now to solve for x, I can divide both sides by 14. And now I have x is equal to 110 over 14. I need to simplify this, however. So I'm going to divide them both by 2, and then I'll have 55 over 7. So my final answer is 55 sevenths. Notice that the very first step I did here was I first found a common denominator. Then I multiplied each term by the common denominator. I simplified, and then I solved for the variable. So let's look at another example. On this example, we have a 3, an 8, and a 24 in the denominator. I need to find a common denominator, and in this case, 8 times 3 is 24, so that would be the easiest common denominator I have. So let's take each term, multiply it by 24. I'm just going to kind of write it right here. And when I do that, I can take 3, and that goes into 24 8 times. 8 goes into 24 3 times, and 24 can just cancel out altogether. So let's rewrite this. We have 8 times 2x minus 1 minus 3 times 4x plus 5 equals negative 19. So our next step is to simplify. So when we're doing that, we have right here, we have something that we can distribute. So let's distribute that 8 first. So we'll have 16x minus 8. On the next one, we have a negative 3. So we need to make sure we multiply by a negative 3. So that means we have a negative 12x minus a 15. And then lastly, we have the 19 that stays the same. So on the left side of the equation, we can combine 16 and 12. So 16 minus 12 is a 4x. And then we have negative 8. And actually this negative, never mind. That should be negative 8 minus 15 will become a negative 23 equals a negative 19. Now we're going to add 23 to both sides. And I have 4x equals 4, or x just equals 1. We can check our work by going back and putting in 1 for x. And let's just do that real quick, just to double check to make sure we did this right. So on this first one, we have 2 minus 1 is a 1/3. 4 times 1 plus 5 is a 9/8 equals negative 19 over 24. And if we get a common denominator on this side, that means we want 24 to be our common denominator. I need to multiply this one by 8 and this one by 3. So that would mean I would have 8 over 24 minus 27 over 24 equals negative 19, and that does work out. We have negative 19 on both sides. So x is definitely our answer here. So we need to talk about domain restrictions. This is the time when we got to limit what x can be, because there's certain numbers that make the denominator become a 0. And as you know, when the denominator of a fraction is 0, it is undefined. So let's talk about that for a minute. Here's an example. We have 39 minus x over x minus 11. So if I make this 11, 11 minus 11 is 0. So we can say that the domain in this case has to be limited to any number but 11. So x can be all real numbers except x cannot be 11. Look at this next one. We have 2x plus 3. One of the ways that we can solve this, and we kind of did this before with this last one, is I just set x minus 11 equal to 0. And if I solved for x, I add 11 to both sides, so then I ended up with x equals 11. And we know that x cannot be that. I'm going to do the same thing with this denominator. I'm going to set it equal to 0 and solve for x. So if I subtract 3 from both sides, I have 2x equals negative 3, and then I can divide both sides by 2. So x cannot be negative 3 halves, because if it is, it will cause the denominator to be 0. So these are restrictions to our domain. And remember, domain means the possible values of x. So whenever we're dealing with rational expressions or rational equations, we need to really keep that in mind. Now, let's look at one more example of this. We have some x's on the bottom, so we know that we have limits here with our domain. And what I want to do is look at that right now before we even start this problem. 2x, if I set that equal to 0, what would x have to be in order for the bottom to be 0 here? Well, if I divide both sides by 2, I have x equals 0. So x is not going to be able to be 0 ever in this problem. And if you notice, it would be the same thing for 8x here. If I set 8x equal to 0 and divide by 8, again, x cannot be 0. Okay? So it can be any number but 0. Now, let's solve our problem here. We're going to find a common denominator, and remember, you have a 3 sitting here with nothing as a denominator, so I can just assume that's a 1. And 2 goes into 8, and we have an x in both of those, so I'm going to say 8x is my least common denominator. So let's multiply each of these by 8x. Okay, so when we do that, x will cancel out here on the bottom, and 2 goes into 8 4 times. So we have 4 times 5, that makes it 20. On this one, the 8x's cancel all together, so we have 9 minus 2x. And on this one, that's a plus, it's going to be 8x times 3, which makes it a plus 24x. So now we can simplify. So I'm going to do that right now. I have negative 2 plus 24, and that makes it a 22x. If I take away 9 from both sides, I get 11 equals negative 22x. And then if I divide both sides by negative 22, my answer here is a negative 1/2. So x is negative 1/2, and we know that that's okay because it's not 0. So this is a good answer. Let's try one more example. In this one, we only have 2 terms. we have this side and this side. And because of that, it makes it really simple. Instead of finding a common denominator in this case, we can actually cross multiply. So let's do that. I'm going to erase my boxes here. I can say this times this is going to equal this times this. Now remember, the only time you can do this is when I have two terms with an equal sign in between them. Has to have an equal sign. So let's do this. 6 times x minus 3 equals 5 times x minus 2. So let's multiply this out. We have 6x minus 18 and 5x minus 10. Now if I get my x's on the same side, so I'm going to subtract 5x from both sides, I'll have x minus 18 equals negative 10. And then if I add 18 to both sides, I'll have x equals 8. Now let's go back and think about what are domain restrictions. Here I have x minus 2. So because of that, x cannot be 2. And on this one we have x minus 3. So if I set that equal to 0, I know that x cannot be 3 either. So this is also part of our answer. We know that x can be 8 and it cannot be 2 and 3. Okay, so that is the end of this presentation. Please let me know if you have any questions, and we'll talk about it in class tomorrow.